these are Algebra 2 notes in the inverse unit. This is the test review lesson. So before we start the review, I'll put up the previous lesson's answers so you can check those and pause the recording if you need to. Okay, so let's start the review. Okay, so first on this one, it says graph the line y equals x as a dashed line. So it tells you here that line needs to be dashed. So let's do every other corner. Sorry, got a little off there. Okay, and then graph its inverse and state the domain and range of the function. So first, you didn't have the little table chart here. You need to know to make the table. Here's for f of x, and for all the points, write the ordered pair. So I'm going to start over here. At that point, it's negative 10, 1. The next point n, this one right here, is negative 8, 5. The next point n is negative 6, negative 2. The next point n is negative 4, 2. The next one is 1, 4. And the last ordered pair for this one right here is 2, 4. Now, let's go ahead and do the domain and range of that function. So the domain, the lowest thing we see in x, is negative 10, less than or equal to x, less than or equal to, and the highest value we see in the domain, or the furthest it goes on the x-axis, is up to 2. The range, we want to look at the y-axis, and the lowest it has, or you can look at the table, the lowest value is negative 2, less than or equal to y, less than or equal to, and the highest value is here, or you look at the graph and see its high as it goes is 5. It passes the vertical line test, so we'll check the function in a minute, or the inverse in a minute, because that's all you're asked for here. Now let's do the inverse. So make a table for the inverse, and that means just switch the ordered pairs. So I'm going to put the y column in x, 1, 5, negative 2, 2, 4, and 4. And then I'm going to put the x column in y, negative 10, negative 8, negative 6, negative 4, 1, and 2. It's just a quick way to reverse the ordered pairs. And then let's graph that function. So go forward 1, down 10, forward 5, down 8, backward 2, down 6, and by the way, connect as you go on this because you'll get lost in the process. So go forward 2, down 4, and forward 4, up 1, and the last one is forward 4, up 2. So the domain of the inverse, we can look in the table or we can look at the graph. The lowest it is negative 2, less than or equal to x, and I'm looking right here, less than or equal to 5. And it should match the range of your other function with x in the middle. The range is still y, but it's in your inverse function. The lowest value I see is negative 10, less than or equal to y, less than or equal to, and the highest value I see is 5. I mean the 2, sorry. Now, don't look just in this column to see if the domain repeats, but I happen to see a repeat of 4 there, but I also see within the graph several places of the inverse where it fails the vertical line test. So no, it's not a function. Okay, so let's do the same thing for the second one. So let's make a table for f of x, which is the graph we see. The first order pair toward the back. This one is -10, 4, -4. The next one in is -7, -2. The next one in is -6, 1. Then -3, 3. And I'm to here, I'm at -1, 6. And then the last point is that one is 2, 8. And for the inverse, I'm going to switch the ordered pairs, f -1 of x, and make your table. And I'm going to put the y column in x, -4, -2, 1, 3, 6, and 8. And the x column in y, -10, -7, 1, 3, sorry, -10, -7, -6. I started copying the other one again, -3, -1, and 2. And then let's draw in the y equal x line, which is every other diagonal, 1, 1, 2, 2, 3, 3. And it should look like a reflection over that. And then graph the points for the inverse. So first graph, go backwards 4, down 10. Go backwards 2, down 7. And connect as you go. This one's a little bit easier. Go backwards 1 and down 6. Go forward 3 and down 3. And forward 6 and down 1. And forward 8 and up 2. And I'm going to look in the table for the domain on the function. Here's my low and here's my high. So for the domain, which is x of the function itself, we go from -10 less than or equal to x less than or equal to 2. For the range of the function, I see the low right here is -4 and high is 8. So we say -4 less than or equal to y less than or equal to 8. And then just to be safe so you don't miss something twice, you could do the same here. We have an 8 and a -4 for the domain. So we have -4 less than or equal to x less than or equal to 8 for the inverse. And for the range, -10 and a 2. -10 less than or equal to y less than or equal to 2. And I don't see any repeats in the column, plus the graph passes the vertical line test. So yes, this one is a function. Number 3, if we find the inverse of the relation, it just means switch the ordered pair. So that one's pretty easy. We'll have 112 5, -3, and 3, 4, 7, 10, and -12, 6. Number 4, we want to find the inverse equation, right? So we need to first change f of x to y, so it makes more sense. Then we're going to switch x and y, so we'll have x equals 5y plus 1. Then we're going to solve for y, and we'll have the inverse equation. So I'm going to subtract 1 on both sides, or move the 1 over, and we'll have x minus 1 equal 5y. Then I'm going to divide by 5. After I do that, I'm going to write the y first. Don't change signs, we're just changing sides. So if y equals, and there's a 1 here, 1/5 x minus 1/5. So with inverse notation, we say f negative 1 of x is equal to 1/5 x minus 1/5. For number 5, we will change it to y equals 7 minus 2x. And then we're going to switch x and y. X equals 7 minus 2y. And the 7's in the front. That's okay. We're going to subtract 7 to get it on the x side. So we'll have x minus 7 equals negative 2y. When you divide by negative 2, I'm going to write the y first. We have negative 1/2 x plus 7/2, because the two negatives make a positive. And then rewrite it with f negative 1 of x equals negative 1/2 x plus 7/2. Okay, for number 6, first change f of x for y. So we have y equals x squared minus 3. And we're going to switch x and y. X equal y squared minus 3. And I'm going to move the 3 over, so change it to plus 3. X plus 3 equals y squared. And then I'm going to take the square root of both sides to get rid of the squared. And when I rewrite it, I'm going to rewrite it with the y first. Y equals, with the square root, you need the plus or minus sign, so you do both sides of the curve. X plus 3. And then you should write it with f negative 1 of x is equal to plus or minus x plus the square root of x plus 3. So you show the reader that's the inverse. Okay, number 7 wants us to find the equation and graph the inverse on this one. So first, we're going to do the same process we did before. We're going to switch x and y, so we need to first write it with y, 1/4 x plus 2. Then we're going to switch x and y, x equal 1/4 y plus 2. Then I'm going to move the 2 so it becomes minus 2, x minus 2 equals 1/4 y. Now to get rid of 1/4, we're going to multiply both sides by 4. And then I'm going to rewrite it as with y in front. So y is equal to 4x minus 8. So your inverse of negative 1 of x is equal to 4x minus 8. And hopefully you recognize these are two lines, so yes, it will be a function because it's not a vertical line. But we'll see when we graph it. So we're going to graph each one. So f of x, m is 1/4, our slope, and b is 2. So make your beginning point on the y-axis at 2 and go up 1 and forward 4. 1 forward 4 and complete out the graph. And down 1 and back 4. And draw in your line. And label that one f of x. Then we need to make a dashed line for y equals x. And then we're going to graph the inverse. So for the inverse, m is equal to 4 and b is equal to -8. So go down to -8 and make a point on the y-axis, and then go up 4 forward 1. And it ought to get them close to intersecting on y equals x. If you drew it close to right, mine seems a little off, but we'll see. It did pretty good. Just a little bit. And label that one f -1 of x. Okay, same thing for number 2. So in this one, I would probably put this in my calculator, put this in y1, and do the table. Remember, for f of x, we want to do -2, -1, 0, 1, and 2. And then do second graph and get the table of values like that because it's quicker. And then your answers would be 5, 2, or you can plug in and evaluate if you like that better. 1, 2, and 5. So this is f of x. And so go backwards 2, up 5. Backwards 1, up 2. And 0, 1, because it moved up 1. And then you can kind of see the reflection on the other side. Sketch it in and label it f of x. Draw in y equals x. And then flip the ordered pairs. So f -1 of x. Write the y column in x. So we'll do the 5, 2, 1, 2, 5. And the x column in y. -2, -1, 0, 1, and 2. And then graph that, and it should look like a reflection. So if we go forward 5, down 2, and forward 2, down 1, and 1, 0, and then kind of reflect it on the other side of that one. Just a little quicker. So they look like reflections of each other. And the inverse is not a function because it would fail the vertical line test. Number 9. There's a piece missing here. We should see a g of x over here. And we want to determine if it is the inverse of the first one. So if we have x minus 15 over 7, let's see if that's what we get when we solve. So we have y equals 7x plus 15. And then when we switch x and y, x equals 7y plus 15. We're going to subtract 15. X minus 15 is 7y. And divide by 7. And you can look over at the other one, and we would have y equals x minus 15 over 7. That's an x. And so they look just alike, so that is a yes. They are inverses. On number 10, it had a g of x over here. It's just missing on this one. Equals 1/4 x plus 4. So we're going to solve the first one and see if it turns into g of x. So first we'll do y equals 4x minus 16. switch x and y, x equal 4y minus 16. We're going to move this minus 16 across, so it becomes x plus 16 is 4y. And then we're going to divide by 4. And I'm going to change the order when I write it. That would be y equals 1/4 x plus 4. So this one is also a yes because it matches g of x. Number 11, it has a g of x out there equals 1/3 x minus 1. And we saw this one in the notes. I'm thinking that's a no because it looks too much like inverses, right? And we'll see what happens. So y equals 3x plus 1. Switch x and y. X equals 3y plus 1. Subtract 1. X minus 1 equals 3y. And divide by 3. So we have y equals 1/3 x minus 1/3. These do not match, so that one's a no. Number 12 says sketch the graph of the function, write the equation of its inverse, and graph the inverse. So when you get to this section, you're going to have to look at that and say, okay, this is an exponential function, so I know its inverse needs to be a log. And we would, most of the time, and our classes use the circle method, we can circle around to see how to write it. So we have log with the base of 1/2 x is the function for the inverse. So we're going to find the exponent table first, always, because we can find that one easy, and then graph it and switch the order pairs for the log function. So I would use the calculator for that, and we want to do -2, -1, 0, 1, and 2. You could work it by hand if you want, but I would put this into y equal and then look at the table, and you should get 4, 2, 1, 1/2, and 1/4. And remember, the exponential function has a horizontal asymptote, so we're going to write horizontal asymptote there, abbreviated. So go backwards 2 and up 4. And this should definitely be decreasing, so it makes sense that we're starting at pi, backwards 1 up 2, 0, 1, down a little more, and down a little more. Sketch it in, and let it approach the x-axis, but don't cross it. So hopefully you remember from the assignments that if they're decreasing, they're going to intersect instead of just be reflections of each other. Sketch in your line y equals x. And they're decreasing because our base is smaller than 1. It's 1/2. And label the first one f of x. Now for f-1 of x, which is the log function, we just switch the order. So we'll have 4, 2, 1, 1/2, and 1/4 for x, the y column, and -2, -1, 0, 1, and 2 for the y column. Then graph that. So go forward 4, down 2, forward 2, down 1, 1, 0, 1/2, and 1, and 1/4 and 2. And then remember, it has a vertical asymptote, so we want to get real close to the y-axis on this one because it's a log, but don't cross it. And then I should have made that look a little flatter so they look like reflections of each other. All right, so when we do the next one, this one's going to be increasing. We still want to turn it to a log because that's its inverse. So if we start at the base and go around, its inverse is log base 4 x. So put this in y equal in the calculator and then do second graph to look at the table to get your ordered pairs. So for -2, -1, 0, 1, and 2, you should have gotten 1/16, 1/4, 1, 4, and 16. Increasing in numbers, and that means our line's going to go up. So let's graph that one, go backwards 2, down a tiny bit, or up a tiny bit, sorry, backwards 1, up a tiny bit more, 0, 1, 1, 4, and 2/16 off the our graph. So it gets big fast with this one because we're repeatedly multiplying by 4. And it's got a horizontal asymptote because it's the exponent, so don't cross x. Draw in y equals x, oh, and label it f of x. Draw in y equals x, and make sure you make it dash because it's not part of which where your ordered pairs fall. It just shows that they are inverses. Then, for the inverse, which is f -1 of x, which is the log, switch your columns, which switches your ordered pairs. So we'll have 1/16, 1/14, 1, 4, 16. And -2, -1, 0, 1, and 2. So they both are increasing even though they're inverses. So go forward a tiny bit, down 2, forward a tiny bit more, down 1, 1, 0, go over 4 up 1, and 16, 2 falls off. And make sure you make it look like a reflection. And it has a vertical asymptote, so don't cross the y-axis. Number 14, it says express each logarithmic equation in exponential form. So we're not going to have to solve, just rewrite it as an exponent. I'll do a couple of the labels. So remember, for a log, it was log B n equal K. I think of the word bank. So this is B, this is N, and this is K. In exponential form, it's B to the K equals N. So the two little ones equal the capital, or however you choose to remember that. So it would be 3 to the 4th equals 81, and make sure that makes a true statement, and it does. So number 15, I'll do that with labeling. The next two we'll do with the circle method. So this would be N and K, whereas the exponent is B to the K equal N. So we want 64 to the 1/3. It means what number cubed is 64 is 4th. And that's true. The next two I'll do with the circle method, so you've seen both depending on what you like. Always start your circle at the base and go around, and it tells you the order to write it in. So we're going to do 9 to the -2, because we went around -2, equals 1 over 81, and check that. And that's true. 17, start with your arrow at the base, circle around. So we have 2 to the 4th equals 16. So we have both methods just the same, and when we go from exponent to log. So now we want these in log form, and I'll do 2 labels and 2 circles. So if we label, we know this is B to the K equals N. But we want our log to be log base B N K. So we want log base 2, 128 equals 7. So for number 19, it's got a weird exponent, but that's okay. We're just labeling and rewriting BKN because that's exponential form, and we want it to be log base B in K. So log with the base of 27, K is negative 1/3. Oh, N is 1/3, sorry, and K is negative 1/3. Then for this one, I'm going to do the circle method. So circle method still works. Start your pencil at the base and circle around. It tells you the order to write the numbers. Log base 4, 1 equals 0. Start at the base, circle around, and then we have log base 5, 125, and the last thing we point to is the 3. So this instead says evaluate. So in other words, we need to find an answer for that one. We don't do logs in our head. So for these, we're going to change them to exponent first. So you put an X in the blank. I like the circle method better. It feels quicker to me. And so I'm going to circle around, write an exponent. So we want to know 5 to the X equal 25. So we want to rewrite it with like bases. I know 25 is 5 squared, so we have 5 to the X equals 5 squared. So we cancel the bases. So X equals 2. For number 23, put an X in your blank, circle around. So we have 81 to the X equals 3. We want like bases. So we have 81 can be written in a base of 3, so you could use your calculator to figure out, or maybe you remember 81 is 3 to the 4th power, but there was an X up there. And with the 3 over here, we have a 1 that's not written. Now we have like bases, so we're going to cancel the bases and solve. So if 4x equals 1, we would divide by 4, x equals 1/4. Okay, for 24, write an x in the blank. I'm going to circle around, rewrite it as an exponent, and then evaluate. Find like bases and solve. So we have 10 to the x equals 1 over 100. Well, first I see, well, I can rewrite 100 as 10 squared, and I want to move it up, so I'm going to make it 10 to the negative 2, so it moves up. So I have 10 to the x is equal to 10 to the negative 2. Now we have like bases, we can cancel them and solve. So x is negative 2. For 25, put an x in the blank, circle around. We have 9 to the x equals 1. And so that one feels a little bit tricky, but so it's easiest just to think about that. Anything to the what power equals 1, so that means x equals 0. So if we put an x in this one, we circle around. We have 125 to the x power. Sorry, I wrote that funny. Let me fix it. Equals 5. So we just need to figure out how many 5s can we get to 125, and hopefully you figure out it's 5 cubed is 125, plus there's an x there, equals 5 to the first power. Don't stop and think that's a 3. You got to solve it out. So we need to solve 3x equals 1. When we divide by 3, x equals 1/3. Okay, then let's look at the review. So this says, what is the effect on the graph of the equation y equals 2x squared when the equation is changed to negative 2x squared? So the only thing new is the negative. So the effect is it reflects, right? Graph reflects down over the vertex or the x-axis, or it opens down. And you might want to say over x-axis because that one starts at the origin. Okay, the function y equals x squared plus 4 is transformed to x squared minus 6. How is each point on the curve of the first function shifted? So you could put both of those in your calculator, or I'm just going to sketch it by hand here rather than open the calculator. So we know if we have x squared plus 4, 0, we have hk, which is 0, 4. So this one starts at 4. 1, 2, 3, 4. And it's a parabola that looks like opens up. This one, it starts at 0, 6 because it has a negative 6. So it goes 1, 2, 3, 4, 5, 6 down. And you could look at that in your calculator to verify it. And it's no change in width or anything. So it's 10 units down. It looks like it widened, doesn't it? Even if you looked at it in your calculator, it looks like it widened, but that's because it started lower, so it'll eventually enclose this one within it, the top one within it. So for number 29, if we do FOIL for first terms, we have 2x squared. For outside, I have 4x, inside negative 3x, so I have plus x. And for last, I have negative 6. Whenever you square one, know there'll be a middle term. It won't disappear because it can't be difference of squares because it's got the same sign. So I would expand it and think of FOIL. We have x squared. The outside is negative 4x. The inside is negative 4x. So we have negative 8x. And the last are plus 16. For 31, first is x squared. The outside are 9x's. The inside are negative 4x's. So I see plus 5x's. And the last are negative 36. Factor completely. We made this kind of small, but these are some of the mental math ones. For number 32, my product is 18. My sum is 9. So I'm thinking, first I thought of 9 and 2, it won't work. So what about 6 and 3? Since the coefficient of x is a 1, we get to go straight to parentheses. It's x plus 6, x plus 3. We get a shortcut for 33 also because there's a 1 in front of x squared. If our product is 18 and our sum is negative 11, want two negatives, so it's negative 9 and negative 2, and then go straight to parentheses. X minus 9, x minus 2. I'm going to come back to number 34 because we need more room to work, and I'll erase around there. Let's first get down to number 35. It's a shortcut. It looks like DOS, but make sure you can't factor anything out first, and we can't. So I'm going to take the square root of both ends since it's difference of squares. This is 3x and this is 5. And we do two sets of parentheses with those. 3x, one with a plus, plus 5, and the other with a minus, 3x minus 5, because that makes the middle terms disappear. Number 36 is a shortcut because there's a 1 in front. Our product is negative 21 and our sum is negative 4. So I'm seeing 7 and 3 with a negative 7 and a positive 3. So it's x minus 7, x plus 3. Number 37 is GCF only. We miss this one more often, but it's really easier because once we factor out this x that's common in both, we'll have x to the first power. So we know we can divide out an x, and then you look at the numbers and you say, well, I can divide out 8x also. So divide it mentally in your head. If I divide 8x out of the first term, I'm left with x minus, and 48 divided by 8 is 6, and it's done. Okay, now 34, I'm going back to that one because we need blankety blank in grouping, and I'm going to work it above it just because I need more room than that to work. So for 34, I'm going to work up here, but show a few things in the bottom. Our product is 12x squared, and our sum is 8. So I'm seeing 6 and 2. So blankety blank means we'll start with our 4x squared, blank, blank, 3, and we'll put in plus 6x and a plus 2x in any order. And it was a plus 3. Then I'm going to do 2 groups of 2, and for speed, I'm going to write it a little quicker. I'm going to just find the GCF of each set. So this has 2x plus, and this has 1. So I know one set of ordered pairs, or one set of our binomial is 2x plus 1. The other one is when I divide it out. I'm going to look here first. That one's easy. We divide it by 1, it stays. So my other pair is 2x plus 3. As long as when I divide this one by 2x, it also looks like 2x plus 3, and it does. So that one's done. Okay, so number 38. Laura and Alyssa took turns driving on a trip. By the end of the trip, they had driven approximately 800 miles. So let's make an equation for that. We have Laura plus Alyssa equals 800 miles total. With Alyssa driving about 1/3 as many as Laura. So Laura drove more, right? So Alyssa equals 1/3 of Laura. Laura drove more. And then you will see this one is not hard to solve. You start thinking matrices or substitution, but then look at the answer choices. So in A, that's out because Laura needs to be higher. Laura should be more. In B, Laura's more, so we'll come back and look at that in a minute, and it looks like Alyssa's about 1/3 of Laura. And C, it's out because Alyssa has the higher number. D is out because Alyssa has the higher number, so we never really had to solve that when B was our answer choice. But you could work it through and see which set of numbers works in both equations. 180 plus 610 is equal to 800, and 610 divided by 180 should be 3. Number 39, Carol's monthly phone bill can be modeled using cost equals $30, I guess, plus 8 cents a minute. Then it says Carol must choose between a monthly increase of $1.50 and an increase of 2 cents per minute used. How many minutes per month must she talk in order for the $1.50 increase to be the better choice? So we want to know, I'm either going to add $1.50 here, or I'm going to add 2 cents here. and we want to know how many minutes per month to make the $1.50 increase to be a better choice. So when will this one be the better choice? So we'll say when is 31.50 plus we would keep the 8 cents a minute less than 30 plus and we the 10 cents per minute added on the back, and that's what we would solve. So first, oh, and these have minutes with them. So I'm going to subtract 30, kind of do it one at a time and subtract 8 cents to get the like things together. So that means we have when is $1.50 less than 2 cents a minute because we subtracted the 30. And then when you divide that out, we get minutes are greater than 75. Now, I'd skipped a lot of algebra steps there, so you may need to think through those and then look back at the answer. So greater than 75, because we want it to be a better deal. None of those are greater than, so you pick D. Dudley's new car gets between 22 and 30 miles per gallon of gasoline. His tank holds 18 gallons. Which inequality best represents the range of distance he can get? So if we do from low to high, right? So our lowest it can be is 22 times 18. And we'll say distance. And the highest it can be is if he gets the 30 miles times 18. And let's see what our answers are. So you do that in the calculator. We would get 396. And on the upper end, 30 times 18 is 540. And they get the or equal symbols. And so that matches answer choice C. A hotel room has 250 rooms with either a queen or king size bed. So that would be queen, let's do it in alphabetical. King plus queen equals 250. A room with a queen size bed is 90 a night, so 90 times a queen plus a room with a king size bed, 110 for a king. And they can get the maximum profit is 25,060. Sorry, that's up there. And then I would do inverse matrices, and I left them in the letters so it would represent the king and queen size because we want to know the queens. So we would have in the calculator, you want to do 1, 1, 90, and 110, or 110, sorry, and 90. Our coefficient matrix C, we'll do the opposite or the inverse on that one. Multiply that times the answer matrix C, which is 250 and 25,060. I'll let you do the calculator work. When you get your answer, it'll be in the form of king, queen, because we put them alphabetical, and see what you get. So you should have gotten 128 and 122, and it asked for the queen beds. So this was king and queen. So your answer is 122. Notice how they have both answers there. Number 46. Jamie has a circular table with an approximate area of 78.5 square feet. What is the radius of the table to the nearest foot? So we're going to find the area of a circle, so we'll do area equals pi r squared. And then we want to find out what radius is, so we know the area. Area is 78.5 feet squared. Pi is pi, and radius squared is radius squared. So I'm going to let you do the calculator work, but we'll talk through the steps. The first thing you want to do is divide both sides by pi. And then you want to take the square root of that answer to get rid of radius squared, and you should get that radius is approximately 4.99, which is B. Number 47 says the energy output from a chemical reaction is dependent on the amount of chemical used. The table shows the relationship. So, what amount of energy output would you expect from the reaction of 29 moles of chemicals? So I think that we would want to do stat edit on this to find out the equation. So hang on just a minute, I'm going to get my calculator. Okay, so do stat edit, and in line 1, put your values in the first column. We have 2, 5, 11, and 14. And in line 2, put the second set of values, 12, 27, 57, and 72. And then I'm going to try linear regression. Stat, calculate linreg 4, and see what it looks like. It's nice, neat numbers, so I think that it's y equals 5x plus 2. And I'll show you that in the calculator again. I can't pull it back up. So if we want to know how much energy would we expect from 29 moles of chemicals, we need to do 5, y equals 5 times 29 plus 2. And you would get 147 equals y, which is 147 joules. Okay, 48. A firefighter's pancake breakfast. We served 340 people and raised $1,800. So that's two answers. If the cost of an adult, so we know that it's going to be adult plus children equals 340 people served. Then we need prices. If the cost of an adult is 7 times an adult plus 3 for a child should equal $1,800. And they want to know the adult tickets sold. So do matrices again. They would be 1, 1, 7, 3 for your coefficient matrix. We'll do the inverse of that one times the answer matrix, which is 340 and 1,800. And when you get your answer back, because we did them alphabetical, it'll be adults, children. Go try that in the calculator. Okay, you should have gotten 195 and 145. So that tells you there were 195 adult tickets. Sorry, tickets. Okay, and last, 49. The amount of an employee's weekly pay, including a bonus, can be represented by that inequality, where H represents the number of hours worked by the employee. If an employee works 30 hours, which of the following isn't a reasonable amount for a week's pay? So we're going to work both ends and find the answer. And then see which is reasonable, and we're going to do between a low and a high. I'm going to grab the calculator, which is going to erase the other stuff. So for the low end, what we're going to do is we're going to put the 30 hours here and type it in the calculator, and the 30 hours here, and calculate a low and a high. So if we do 650 times 30 plus 75, the lowest is 270. And then for the highest, we'll do the same thing, but with the 7 times 30 plus 100, a little bit higher bonus, is 310. So we want to know what number falls between those, or the closest to the middle. Well, 220 is too low, 265 is too low, both 270 is the low, and 300 somewhere in between. So this is your best answer because it's in between, since this is your low amount. And it just said less than, so we got to be greater than 270. Okay, good luck on your test.